Good morning. Today we're looking at section 10.1, which is rational exponents. So today we're just going to look at how you can manipulate around and move exponents around to make the problems easier to deal with. So some of these base concepts we've already touched on this year, but today we're really going to put them together. So as you can see here, we talked about the fact that if you take something to the 1/2 power and you square it, right, you get back to the original number. Okay, so anytime we have square root, we can write it as to the 1/2 power, or anytime we have the 1/2 power, we can write it as the square root. And that will be true for any root. So if you have to the 1/5 power, right, that's the same as the 5th root. If you have the 1/8 power, it'd be, so the 8th root, so on and so forth. Okay, and then again, if we break that down and we say, okay, well, what happens if we have something to the 2/3? Okay, well, then you can write that as something to the 1/3 squared, or you can write it to squared and then to the 1/3, which then just allows you to move it around. Basically, you're looking for easy to work with numbers. Okay, so right here's our basic formula. Right, if we have a value that's raised to the p divided by q, okay, whichever one is easier is what we can do. We can either take the q root and then raise it to the p power, or we can take the p power and then do the q root. So it just depends on which one is easiest to deal with. So a number 1, for instance here, right, we have 81 to the 3/2. Well, the halves, right, would make it the square root. This is already a perfect square. So if we write this as the square root of 81 to the 3rd power, okay, then that just gives us the square root of 81 is 9. 9 to the 3rd power is 729. Okay. Number 2, we have 8 to the negative 5/3. Well, we have 8 and we have this cube, right? This cubed root that has to happen because it's divided by, right? We have this divided by 3 up here, okay, in our exponent. Well, 8 is a perfect cube, so it's the easiest thing to do here, right, is to write it out where that is the cubed root. So if we write this as the cubed root of 8 to the negative 5th, we can now take the cubed root of 8, and that's just 2 to the negative 5th. Now, if you remember, right, negative exponents just turn it into fractions, so this is really 1 over 2 to the 5th power, which means it's really just 1 over 32. Okay. Number 3, we have 9 to the 1.5. Okay, so remember 1.5, right, when we turn that into a fraction is 3/2. So this is really 9 to the 3/2. Again, we have this 2, so we need the square root. This is a perfect square, so that's the easiest thing to do first. So we're going to take the square root of 9 and raise it to the 3rd power. The square root of 9 is just 3, so 3 to the 3rd power is just 27. Okay, number 4, okay, we have this cubed root of 81, okay, in the bottom here. We have 1 over, right? So we know that we could write this as a negative exponent to begin with, so I can write this as 81, right, to the negative 1/3, because this is really 81 to the 1/3, but since I want to write it without the 1 over top of it, I make it the negative. So 81 to the negative 1/3 raised to the negative 3/4. Okay, now that I have this situation, I can just multiply my exponents, because we know a, or any value raised to the m and to the n, you can just do m times n to find out my exponent. So this would just give me 81. Negative times a negative cancels each other out. The 3's cancel each other out, and we're just left with to the 1/4 power. So this is 81 to the 1/4 power, which happens to then become, right, the 4th root of 81, and the 4th root of 81 is just 3. Okay, number 5 here, we have the square root of 1/3 times the cubed root of 9. Okay, so remember, right, if this is the square root of 1/3, that's really the same as 1 over the square root of 3. Okay, this is the cubed root of 9. And remember, 9 is the same as 3 squared. So you could rewrite this as the cubed root of 3 squared. Now this situation right here, we can again get rid of this fraction by writing this as the square root. Oops. We're going to write this as 3 to the negative 1/2. Because this is the square root, right? So the 1/2 power, to get rid of the fraction, we write it as the negative 1/2. Okay, then this is really 3 to the 2/3 power. Okay, our bases are the same, right? So we just add our exponents. So this is 3 to the negative 1/2 plus 2/3. Okay, and when we have that, right, we can add those together. So remember, negative 1/2 would really just be a negative 3/6, and 2/3 would be a positive 4/6, which gives us just 1/6. So this is 3 to the 1/6 power, which is just the 6th root of 3. And that would be your final answer, as far down as you can simplify. So really what we're doing is we're just manipulating all of these around to be able to figure out, right, what's the easiest way to eliminate as much as we can. Okay, so number 6 says, write the cubed root of 9 in exponential form and in simplest radical form. Okay, so if we have the cubed root of 9 times the square root of 3. So remember, 9 again can be written as 3 squared. So this is really the cubed root of 3 squared times the square root of 3, which would mean this is 3 to the 2/3 times 3 to the 1/2. Okay? And when we do that, if we multiply the bases, that means we're going to add the exponents. So if we do 2/3 plus 1/2, that's 4/6 plus 3/6, which gives me 7/6. So that's 3 to the 7/6. Okay, so that would be in my exponential form. Okay, and then when we want to write it in the simplest radical form, right, then that would be, we'd have 3 out here, and then we would have the 6th root, right, of the 7th power, but, right, we can simplify this down, right? This is really 3 to the 1st power times 3 to the 1/6 power. So 3 to the 1st power we just leave as 3, and 3 to the 1/6 power is just the 6th root of 3. So it's 3 times the 6th root of 3. Okay, for number 7, okay, we're supposed to be solving this, so we can do just like we solve anything else. To get rid of the 6 in front, we can divide both sides by 6, and that gives us x to the 2/3 equals, well, 54 divided by 6 is 9. Okay, now we can just raise both sides to the 3/2 power, right? Because 2 times 3 is 6, 3 times 2 is 6, so that just leaves us with x. And then that's going to equal the square root of 9 to the 3rd power, which the square root of 9 is 3 to the 3rd power, so x just equals 27. Okay, for number 8, we're going to follow the same type of steps, right? We're just going to follow it like we would anything else. To get rid of minus 3, we're going to add 3 to both sides. We get t minus 4 to the 2/5 equals 4. And then we need to get rid of the 2/5, which I probably should have written a little bit higher. Okay, and to do that, we're going to raise it to the 5/2. So this side, right, those cancel each other out, and we're just left with t minus 4 equals, and then here this is going to be the square root of 4 to the 5th power. Now the square root of 4 is just 2, so this is really just 2 to the 5th power. has to equal t minus 4. So 2 to the 5th power is just 32. So t minus 4 equals 32. We add 4 to both sides, and we get t equals 36. Okay. So those are the examples we have. Your homework is down here at the bottom of the page. We're doing page 458, 9 through 49 odds. Good luck, guys. Have a good day.